Okay, so this is the Power BI I just created, and the last one that I've created, that PBIX file. Okay, I'm opening this one, a new one. Over here, we connected with the Excel workbook last working day. Apart from that, you can see we have import from SQL Server. SQL Server is MS SQL Server, Microsoft SQL Server. This icon is over here as well. We can directly click on Get Data, and we can get all the options over here. Excel workbook, Power BI, semantic models, lots of sources are there. I'm clicking on more. I'll be get some more thing over here. Okay, so you can just in all section, all the source systems are there. There are lots of section, more than 100. Okay, it nearly more than 200, 300 source system. Just like Salesforce Object, Salesforce Reports, Google Analytics, Adobe Analytics. Okay, so it's very, I improved tool and have the interface to connect with each of the source system, each of the technology. Okay, you can see it. Let me search with MySQL database as we have MySQL at my system. I'm just opening it parallelly. My MySQL database at my local system. Okay, I'll be trying to connect this MySQL database. Okay, okay. So I need to establish connection with MySQL database. Yeah, hi Rosni. Rosni, yesterday onwards we are learning Power BI.
Okay,
Uh,
hi.
yeah, hi.
Mhm.
So Power BI, the first day's class, we have covered most of the thing actually, and
Okay.
we have. I'll be showing these things to you as well, or you can just quickly check the recordings. A full
Yes.
report construction demonstration was there in last day session,
Okay.
and because from the students, he also telling to connect a different database system and pull the data from that database. Yesterday we have the demonstration on top of Excel file. I have an Excel file. In that particular Excel file, there are fact and dimension tables. I pull all those things over here and created the visualization techniques. So today I'll be going to connect a relational database management system. So I'm planning to connect this MySQL database what we have demonstrated during SQL classes. Okay, so
Okay.
just this is the Power BI. If we just double click on the installed software Power BI desktop,
Mhm.
so I can click over here, get data. How to configure a MySQL database? You can search MySQL, or you can find these things from here or here. Click on database. Only database part should be there. And Power BI tool is very, nowadays very advanced, and the lots of interfaces are there. We can connect any of the databases. You can see lots of databases names: Microsoft SQL Server, Microsoft Access, SQL Server Analysis Service, Oracle Database, IBM DB2. Lots of things are there. So whichever source system we can get, we can easily connect with our Power BI. Just we need the proper credential to connect it. Okay.
Okay. Okay.
Okay.
Thank you.
Okay. So I'm going to connect with the MySQL database. Okay, let me search with MySQL over here. Yes. So SQL Server. Let me put the server name. Okay. Server name. We can put MySQL 80. Database optional. I can put. I cannot put. Okay. Here is the option to put username and password, but I'm not sure. They are giving me option to connect it directly taking the Windows authentication. I hope it will not work. Let's see. SQL Server unable to connect. Yes. So the connection was failed. Let me take MySQL from here. Yes, MySQL database. Okay. Server name I can put my local instance that is MySQL 80. Let me put the same database name. Uh, database name we can put anything. A server name it should be my local host. MySQL 80. Okay. Advanced options what are there? Command timeout SQL statements. No, do not need that one. Okay. Clicking on OK. We couldn't authenticate with credentials provided. Please try again. Database username. My username is root. Password is 27. I'm going to connect it. I'm I'm authenticating over here my real MySQL and let me choose a database from your Tetra training. Training. Yes. You can see now it's successfully able to create the database connection with MySQL database over here. I can see whatever table I have mentioned over here. You can see in Tetra training database schema, whatever tables are there, it is successfully pull the same information in Power BI window. Let me show you the table list. Yeah, it's there. It's same as well as here as well. Employee view, all subject one, employee designation. Those are the things. Okay, we can choose any one of the table or multiple table from here. So let's pick up employee table. If we want to transform anything, we can transform. Otherwise, we can directly go for load data. The similar things we have learned the last working day. Vikas didn't join, so yeah, I think as per his request only, uh, the session I was just showing him. Okay, he must be checking in over here. So let's find the same over here. The particular table has been loaded. Those are all the columns. Date hierarchy. Yes, everything is there. Only one single table is there. So that is why nothing for data modeling is required over here. This section is for data modeling. Okay, you can see the data views. It's fine. Okay, so now we can create any charts and graphs. We have lots of things over here. Just like we can call a bar chart again. Okay, in the bar chart, you can simply call Employee first name, salary, last name, department. Let's take department versus salaries. Okay. By default, it should be summation of salary. We can create new measures as well. Suppose I'm going to create a new measures. Okay. I can just put measures value as average of the salary. This kind of customized measures we can also create over here. We can give it a name avg underscore salary. Okay, and the new measures has been created over here. So earlier it was salary, it's a total salary by default. You can see a summation sign is there. Okay, and I can also find this thing at the bottom section. Now I'm just replacing this thing over here. You can see sum of salary. Instead of doing that, I'm removing this field and adding average salary. Okay, so we can get the average salary based on department. Okay, this kind of structural things we can do this. Try this over here. We have filter pane as well. Yesterday didn't discuss about that one. So based on any fields filter, we can implement some filter over here. Okay, suppose department. I don't want to see all the department data. Suppose I want to see BA, BPO, and IT only. Okay, HR, BYT, I don't want to see. So this is the we can put the filtering operation as well on top of any field. And this is the option for locking filter. Maybe I'm the developer. I don't want anyone to open the filter if they are having PWDX file. Then they can also open it. But I don't want that to be opened by anyone. So I can close this. Lock filter. Okay. So those are all the steps. We can create different visualization based on different uh, I mean visualization technique. As I mentioned, we have different dimensions as well. We have different measures, just like experience. People versus experience, you can create another graph. Okay, I'm creating another graph. Employee first name and their experience. We have different chart option as well. So this kind of what is your criteria? What kind of KPI you want to see in the dashboard? Just quickly build this thing up. As we have single table, so do not have to think about the data modeling. Yesterday we showed one thing in data modeling. Yesterday we have multiple tables, and we need to keep proper data modeling. Otherwise, the particular value will not be showing over here in the reporting layer. Okay. Okay. So this is how we can connect with the database. We have connected the database and pull the data from there and creating charts and graphs on top of it. There is various charts. Yesterday also showed some pie chart. We have simple table as well. Let me show you quickly. I'm just choosing a table, and whatever things I want to show in the table, just select it over there. So this is how it should look like. Okay. Okay. So that's all. As of now, we can see as a Power BI basics, those are sufficient, whatever we are learning from the last day. In depth, if you are just going to learn in the depth, then there are lots of things just like conditional formatting, some, I mean, good visualization, some colorful things as well. So those are very, very minute things you need to learn differently for that thing. But as for the basics things, how to create charts and graphs with various dimensions, you need to know first the KPI. What is the KPI you need to design over here? And when the KPI is fixed, then you need to choose the proper dimension and fact from the source tables. Okay, so this is the overall concept over here. I hope this is clear. Any doubt from anyone? Is it clear? Okay, I hope yes. Yeah, I'm closing this Power BI desktop version. Okay, for Rosni, Power BI desktop we can directly install from Google or any other websites. Google, or we can also download it from the App Store of Microsoft. Just find the apps, particular Power BI app in your App Store and get it in your system.
Okay, sure.
And we are creating this kind of visualization things in our local, and this is a publish button. When our things are ready, when the dashboards are ready, we can publish it to the Power BI server or portal where everyone can see it. Okay, for any kind of editing or development part, we need to open this file in our local system. When all the things are ready, just go and publish it into the server. That is all.
Okay.
Okay, I'm now closing this thing and moving ahead with the Python exercise part. Okay, so that we can close Python topic by today. I open my PyCharm. I have done the coding part. Let me open the exercise. Okay, so we learned how to use Python extraction, Python transformation, and data loading part at the target database. So similar kind of things I have given you as an example or exercise form. Create data frames based on each of the three subject areas. Let's open this Excel. Customer, outlet, and product informations are there. Okay, these informations are here. And what we are going to do as per the exercise, we need to import the data from the external Excel file and create three different data frames. Each of the individual sheet we are having customer, then outlet, then product subject areas, and we're going to call each of them and create individual data frames based on each of the subject areas. So this is the first thing in ETL. The first thing is extraction. We'll be doing the extraction by this step. This is very simple. We all learned it, and how to do these things. We can use pandas. Let me just uncomment those stuffs till this point and comment out the rest of the thing. Okay, so we are just calling this stage2.xls. Only the difference between these are sheet name equal customer. For the first customer sheet, it's DFC. DFC for data frame customer. Okay, data frame customer. We are creating data frame customer in this way. Then we are creating data frame outlet, DFO. Sheet name equal outlet. Okay, and this thing is also another parameter, header equal 1 means the first row is a header. Just to identify what is header, I mean the first row is a header or it's the data itself. As this is header, so I'm mentioning in this way. Okay, so while calling the CSV, we can directly call the path, and CSV file is automatically imported. But as this is an Excel file, so we need to make some additional parameters over here. I hope this is understandable. So like the same way we create three different data frames for three different subject areas: data frame customer, data frame outlet, data frame product. Okay, and I'm printing all those data frame individually one by another. Let me run it. Okay, so we can see customer ID, name, purchase date, product ID, and outlet code. So this is from customer data frame, then outlet data frame, then product data frame. So all the three data sets were successfully extracted. Our extraction part is completed. The first step is completed. Now moving to the second step. Create a data frame having the fields customer name, purchase date, outlet, branch name, and product name. So we need to create a single data frame from all those three data frames where we should be having purchase date. I'm just highlighting customer's name. These two fields are there from the first data frame. From the second data frame, we are having branch name, having product name. Okay. So these four columns should be populated in a single data frame. So this is at the transformation layer. We are going to transform the data frames. We need to merge the data frames. Merge means join. We'll be joining the data frame, and in the final data frame we should be having all those four columns. We should be having relationships between the columns, between the tables. So just like if we want to pull outlet, we have the common column outlet underscore cd over here and outlet underscore code over here. Based on these two matching columns, we'll be pulling this particular column from here to here. Okay, and with the intermediate resultant data set, after joining between customer and outlet, we can pull this column again, and based on product ID over here, it's also having product ID. We can join product table and pull product name. So this is the fundamental steps. Let me repeat. In the customer table, we are having all those foreign keys: product ID, outlet CD, outlet code, customer ID. Okay, so product ID should be, I mean, it will be useful while joining with product table. and outlet underscore code should be useful while calling sorry while calling branch name. Okay, outlet underscore cd is the primary key over here, and outlet underscore code is a foreign key over here. So based on the join of outlet underscore code and outlet underscore cd, we can pull branch name related information into the joined data set. Okay, let's really go to the transformation part over here. Let me just comment this thing out. First of all, I'm creating df1, merging dfc and dfo, means customer and outlet data frame based on outlet code. It's a inner join, so I do not put the parameter how. By default, it should be inner join. Okay, how we can join in data frame? Already we have learned all those things in our Python pandas days on that. In detail level, we have learned all those things there. So we are just going to implement the same thing over here in this. So we are joining DFC and DFO based on outlet code and outlet C. And we are storing all the result in an intermediate data frame called DF1. We are creating another data frame DF2, merging this intermediate data frame with DFP, means data frame product, based on product ID column. Okay, and df2 is having all the records whatever we required, but it is having some extra records as well. So we are doing a slicing. How to slice means how to do column level filtering. Whichever column is required at the final output, we can print it over here. Okay, so df underscore final equal df2 name, purchase date, branch name, product name. We are having all those informations over here, and we are creating our final data frame that is called df final, which are having all those required columns. Okay, and this is the printing of the df underscore final. Let me just show this thing whether it's properly doing or not. Yes, so till that part it was extraction layer. Now I'm joining between outlet and customer data frame. We are having all those columns. Then again I'm joining over here with product information, and finally we are having this particular columns, the required one. Customer name, purchase date, branch name, product name. Okay. Now our final target is load this final data frame into a Snowflake database table. Here, this is the new thing I gave to you for solving it. So Snowflake database, we need to create an account. I hope you have created one account for Snowflake database, and you need to put the same over here. Okay, I found Ayla. Ayla, is this your first class for today? Ayla, Alekia, is this your first class that you have joined for today? You're already an existing student. Okay, not sure. So our final thing is we need to load the final data frame into a particular table in Snowflake database. So last day I showed you how to create a Snowflake database. Snowflake database, actually it's a online cloud-based database system, and it's very hot topic in the market. So this is how I told how I have created, and this particular link has been generated in my mail ID. So I'm just going to launch it over here. So what is my password there? Okay, not password. This is my username. Password. Okay, this was the password. I'm going to open a sheet. Yes, you can see I'm entering into Snowflake database. Those are the particular. This is the database that I've created on last working day. Create database training. Okay, so let me use the same database to create a new table. I'm going to the coding part now. Okay, so we also used a new, libraries called SQL Alchemy to create any external database connection string. I'm commenting out this section, commenting. So I'm passing all those things in a variable account identifier. So those are every important parameters will be required for authenticating Snowflake database. The first thing is account identifier. So this is my account. This is my Snowflake account, JVSBZL till this part with a hyphen. I can get this kind of account in my mail ID as well. So I have directly copied the account from my mail ID. Okay. So this is the account starting from here to here, including this hyphen. Okay. Okay. Sorry. So this is the account identifier. Username, the username by which I have logged in there. Password, I'm putting it over here. Database name, yes, it should be different. It is tetra underscore training. Schema name is this actually. Let me check the database. Okay, no, schema I haven't created. This is the database. Let me create a schema. Whether there is any schema underscore tetra training. Yeah, it's public schema. We can create the table in public schema. No issue, or we can create a new schema for our training purpose. Okay, as of now, I'm putting it public where it was earlier. Okay, database name is this, schema name is this, warehouse name is this, compute underscore WH. Okay, let me just confirm yes, compute underscore WH. And I need to also specify the role name. Role name is account admin. Just re-ensuring this part. Role name is account admin. So all those parameters are required to authenticate Snowflake database. Unlike MySQL, there is lots of parameters. In MySQL, we have very simple parameters just like host name, that is my local host, username, password, port number 3306. Okay, and this kind of database schemas. So those are the mandatory things. But over here, we have lots of things just like database name, warehouse name, role name. So we need to put all those mandatory steps over here. Now I'm calling the engine and I'm calling all those individual parameter with a F string. Okay. User, it's coming from user, password, account identifier, database name. Just like the similar way we have connected from MySQL database, we are connecting to Snowflake database with all those parameters. Here we are just passing the parameters, creating an F string. Okay. All those parameters I have put over here, just calling it over here in this line. Now I'm using create engine module, create engine, which I imported. It's a particular class from SQL Alchemy. So create engine class I'm calling, passing as a input parameter engine over here. Okay, and creating this connection CON, and I'm passing a print successfully connected. Okay, after that connection, this line is not required. Let me delete. What is my final target? I need to load this data frame df final into Snowflake database. So I'm just putting df final dot to SQL. This is my new table exercise underscore Python. We already checked there is no table is there. Under public schema, there is no table. We are going to create a new table exercise underscore Python. Okay, which will be pushing this data frame into Snowflake database using this connection as a connection parameter over here. Index equal false because this index Snowflake will not be going to capture. Snowflake will be capturing starting from name, then purchase date, then branch name, then product name. Index equal false. If exists means if the data frame is already existing, then it will be replacing it. Okay. Let's run it. Successfully connected. My program didn't end yet. Yes, the execution has been ended. Now let's see into Snowflake whether it's really pushed into Snowflake. Uh, it's not there. Let me refresh the page. I'm going ahead with a hard refresh. Underscore tetra training. Public tables. Yes, new table is pushed it over. It was pushed over here with the name exercise underscore Python. Let me just have a quick print on top of it. Use schema public. I'm just going inside public schema and then I'm just going to put a select star from exercise. Yes, it's there. Sorry. Underscore Python. Yes. So this is the output. You can see whatever we can fetch it or create in a final data frame list. Name, purchase date, branch name, product name. We can see it over here as well. Name, purchase date, branch name, product name. Okay. I hope there is no issue from your side. So we are successfully able to load it. This is the last step of an ETL. How we can load the data. Whatever cleansing and transforming data are there, we can directly load it over here. Okay. Hope there is no doubt. If there is any, please tell me. This is the exercise and we just completed the fourth step. Okay, I hope it's clear if there is no question. So that's all for today's chapter. The next week should be the last week for the existing session. We'll be having some concepts on top of cloud computing as well as big data Hadoop part. Okay, and the next week should be the final week for this ongoing session. And again, the next session will be started maybe from 25th March. Okay, so that's all for today. If there's any doubt, you can tell, otherwise, you can drop off. Okay, okay then. Thanks everyone. Thank you. Bye bye.
Thank you.